So I have a few announcements before we get started in class. And as requested, after announcements and muddiest points, we'll have a couple of the function presentations. Okay, so assignment 3 has been returned. We tried to give you as much feedback as possible. We did take a point off for certain reasons. So yeah. So if there are any questions about that, please email either Eric or me. So presentations. The presentations today are going to be by Lindsay, Sarah, Lisa, and Amy. And the number one thing I do want to talk about before we do anything else is that the midterm project is now available. And I'm going to show you where that is. It's in the regular projects, and some of you have already derived your projects. So I just want to go over it with you and just kind of field any questions in case anybody has any. As on a related announcement, would people like to spend next part of next class just kind of working on the midterm, just having time to work on the midterm? As just kind of an office hours, just hit yes or no in the participants tab.
When is the midterm going to be due?
So the midterm is going to be due February 12th. So that's next Friday. So you will have time to work on it before it's due.
Okay, that makes sense.
So votes, yes, no? Okay, I've got a few yeses. Yes, yes. Okay, unless there's a flood of no's, I'm going to spend part of next week and it will be, so what we'll do is we'll probably have a shorter class session next time. We'll mostly be talking about lists. We may do a little bit about dates. And then we'll spend the rest of, after the presentations, we'll spend the rest of the time that will just be kind of to work on the midterm, and I'll just be here in case you have any questions or you want to run something by me. As most of you know, I've done the presentations. I try to give as much feedback as I can. And Eric will also be here, and he will be able to field some questions, at least until it's 5:45, right, Eric? Is that when you have to leave?
Yeah, a little bit before that, but yeah, around then.
Okay, yeah, so he'll be there for about an hour after the rest of the class. Okay, so we'll spend about an hour and a half of next class just as kind of drop-in sessions, just to make sure that everyone has kind of the support they need. So this is the midterm. I'm just going to open it up. So we're in the midterm project. I'm just opening up the midterm project.rmd. And I just want to kind of go through it. So like I said, the point of the midterm is really to make sure to kind of show off the skills that you've learned so far, and like visualizing data and doing the data wrangling and manipulation. So it is going to be 60 points total. The goal of the midterm project is, like I said, is just to showcase skills that you've learned. The midterm is open note, open book, open anything. But my one caveat is if you borrow somebody else's code, you have to attribute them. And what does that mean? So if you're in your comments, if you use like somebody's code to manipulate some data, like I just want you to put in a comment like, you know, this code came from, and then put a link to the source. So again, you know, we learn the best by like from others and understanding each other's code, but I do want this to be fair to people who have kind of put their code out there. Okay, so this is, I mentioned this before, but this is a little more specific. So I want you to pick a data set. The data set should be this should be 2,000 rows or less, and have both categorical and numeric variables. So there are, this is, like I said, this is Tidy Tuesday, and I'll go over that link again. This is a kind of weekly data science activity from the R for Data Science group. And they basically release a data set a week. So there should, hopefully there should be something of interest. The other option for data is you can use, if there's another data set that you're interested in, or there's data of your own that you want to look at, you can use it, but please make sure that it's de-identified. Like, again, you know, I do want to encourage you to like kind of learn with data that's interesting to you, but we do have to be cautious about that.
Ted, you have a couple questions.
Sure.
One involving, I guess, attribution, and then one is OGAP code. So. Yeah.
So yes. So you can use so for the code, yes, like using the recommended code on GitHub. That's just a simple, yeah. This code is like derived from the Tidy Tuesday. So going into that, Natalie, so if we use internet resources to help with some code or solve some issue. So yeah, if there's a link or a reference that you can make as particular as you can, just basically paste that in as a comment in the code. Did that answer your question? Okay. So we'll have some time well, Eric is going to be gone early, but I'll have some time at the end of class, and you can schedule some time with me now, or you can come in during office hours on Friday, or you can, if you need some time, there's no time that works for you, you can also schedule me with the Calendly link, and I'll send that out as an announcement. So we want to make sure that you're going to have a research question attached to your data sets. And we just want to take a quick look at the data and make sure that it's appropriate for your question and that you can answer the question. So working together. So, you know, I encourage people to work together if they want to. But number one, you do have to divide the work equitably, and you have to note contributions. You have to note who worked on what. So if you just put like notes in the text, like, you know, X worked on this section and Y worked on that section, just kind of, and please let me know if you, Eric or me know if you're going to be working together. So if you don't have any acknowledgements of contributions, that's going to be minus 10 points overall. And that's out of 60.
And then Ted, about the attribution of finding like internet resources, somebody had another question, like on homework, I think.
Oh yeah, so is that something you want us doing on the homeworks as well going forward? So I would say it's good practice. I mean, just to be transparent. I will say I'm not going to make it a requirement, but it's strongly desirable. It's good practice to have in mind. So Brady's question is, can we use a data set from a different class if it does not contain identifiable information? I will say yes, with the caveat that we look at it and we understand what your research question is. So yeah, so I mean, as long as I know where the data is coming from. So hopefully that answers the question. So I'm going to go through the rest of the exam now. So please note, I'm going to take off points if there's not observations and notes in your R Markdown document following the code. I do want you to think through and reason through your analysis, even if your thoughts are kind of preliminary. So there are some various sections that I'm just going to go through. So this is the defining the research question. So this is 10 points. So you're going to define the research question below. What interests you about the data? What is a specific question you want to find out about the data? And then given your question, what is your expectation about the data? So do you have a certain expectation of what the data is going to show you? Do you expect, for example, if you're thinking there's going to be a correlation between two variables, like, you know, how strong do you think that correlation is? And again, like, you know, your expectations should be answerable by a visualization and by data wrangling. So loading the data is 10 points. So what I want you to do is load the data, and I want you to just make sure that you've loaded it correctly. Use glimpse or skim on the data. And if there's any quirks that you had to deal with, so if NA was coded as something else, or you had multiple tables, just please make some notes here about what you need to do to start transforming the data in the next section. And also make sure that all of your data types are correct. I am going to take off points for this. So make sure you set your NA arguments correct. Transforming the data, this section is 15 points. So if you need, if the data needs to be transformed in any way, do it here. And this also, shoot, I think so at the very least, I need to revise this. I was going to say you need to make a subset of the data. And basically ask a question of the subset as well. So that would be like the very bare minimum to kind of get through this section, is to subset the data and think of a question to answer of the subset. I'll update the midterm project. Let's see. So is there any questions about that? So if you are, we're going to be talking about joining tables today and merging them. You get some bonus points if you have a data set that requires that. But we'll be talking about this. So you have to reason through why you should use, what kind of join you should use on these tables. So I'm not going to provide any credit if you don't. Then here, you're going to show your transform tables, and then use any tools such as glimpse, skim, or head to kind of show that you've basically, you've transformed the data into the point that it's usable. Take a look at the ranges, expected values for the variables. So are they in the units that you expect? And if they aren't, why or why not? Are there any questions about this data transformation section? It is kind of intentionally made flexible, like so that you can try various things out on your data. But again, you know, it's not like 100% of the assignment. Okay. So visualizing and summarizing the data. So this section is 15 points. I want you to basically think of use a group by summarize to make some sort of summarization of the data here. So like, for example, with penguins, your summarization might be by island, or it might be by penguin gender, or it might be by penguin species. And the summary here should be relevant to your research question. What are your findings about the summary? Are they what you expected? And then in terms of visualization, I want you to make at least 2 plots that will help you answer your question on the transformed or summarized data. So this could be, you could do one example you could do is you could do, you could take 2 different subsets of the data and you could kind of make 2 plots comparing them. Or you can do something like, you can look at the distributions using a box plot on the full data set and then kind of drill into a subset of the data and kind of look at the distributions, something like that. So final summary is worth 10 points, just to summarize your research question and your findings. And just again, to address, are the findings what you expected? Why or why not? So again, it's made to be flexible, and it's really made for you to kind of show your stuff and have some fun with it. Are there any questions about this?
So just so I'm understanding correctly, Ted, so when we're picking, so we're going to pick like a data set from that link and then kind of make an appointment with you to talk about it to make sure that it's a good data set.
Yeah.
The research question, I guess, what I'm asking would be like, how in depth of a question are we asking? Like, is there an association or like? So
like past questions, so someone used a Spotify data set and it was something like, it was something like on the order of like, is 90s hip hop more popular than current hip hop right now? Something on that level. So it doesn't have to be a very in-depth research question, but the key is that, are you going to be able to answer it with your data?
Okay, that makes sense.
Good question. Any other questions? Are people feeling okay about this?
Do you have like a link to schedule appointments with you?
Yeah. So you can use the Calendly link. So I will send that out in an announcement. I would prefer, if you can come to office hours, please try to come to office hours. I mean, that's what it's there for. So any other questions? And like I said, this is due on the 12th, which is Friday. Please let me know if you need, I may grant extensions. I don't want to, I mean, because I want to kind of I want to grade these on the weekend and get them back to you as soon as possible. So how should we notify you of your data set and research question? So I will say, like, you can email us. But yeah, we would prefer if you did make, like, if there was an appointment with us and you just kind of came in for a quick talk. So no more than 5 minutes. Okay. Any other questions? And the sun is right in my eyes, so I'm backing up. Okay, so that is the midterm. So the Shiny workshop, all of that information, I got several emails asking if it was going to be online. If you registered for the workshop, all of the materials are online. If not, I will paste the link into chat. Just a second. So this is the full workshop with an RStudio project. There are slides and video. So you can it's made so you can do it on your own. The recording of the workshop is just of the workshop, obviously. So it's not exactly like 100% polished, but it should be okay. So there were a lot of questions about across. So the last thing I want to show you, and you can do this in your project or your part 5 project, which I'm going to start opening right now. So like I said, I have put together like a general purpose tutorial about tidy select and across. And this is an option if you want to learn more about this. So the package is called tidyr. So if you type in library tidyr, and then there's a command in there, learn tidy select. So this will open up a tutorial window. And this is what's called a Learn R tutorial. And so it takes you through all of tidy select, and then it talks more about across. This is I should have added this into our notebooks, but like Jessica had kind of already added her section, but this is, I spent a lot of time kind of working on this so that it was kind of applicable to as many people as possible. So, and then I will try to find better examples of that across with the dot notation. There's a reason I don't like teaching that notation because I think it's really hard to understand. And it's not really used that often in the tidyverse. But I will try to put together examples of that for another class. So the one thing about this tutorial is when it basically locks up your RStudio Cloud. So to get out of it, you need to hit this stop button in your console. So it's this little red button here. You hit stop, then the tutorial will stop. And you can kind of go on using your project. Any questions about the tutorial? Okay. So let's go over mightiest points from last time. So yeah, like I said, so there was a question about how functions that you saw used with across work. So this tutorial should really help you kind of step through that if you're interested in that. Another piece of feedback, still not clear why we create a factor. They did the gender code without factoring, and the table was the same when they included the factoring code. So we are going to be talking much more about factors today at the end of the lab. So for scale Y, scale X and Y continuous was confusing. So I will try to come up with some more examples for you to try out. This is a really handy reference. I use this all the time, like when I'm trying to figure out how to customize tick marks and labels. And there's a little discussion about scale X and scale Y continuous in there. Another note, so there was still some trouble with case when. So I put some example, I put an example tutorial in the part 5 folder. Actually, I think the most useful way to kind of learn case when is if we come up with like a way we want to encode a variable, and we can do that with the maybe with the Penguins data set. Any questions about the muddiest points, or is there any other muddy points you'd like to see me address? Okay, so why don't we, I'm going to stop sharing my screen, and why don't we start, so why don't we do two of the function presentations right now, and then we'll do an hour of, we'll take a break, we'll do an hour of lab, and then we'll finish with the last two. So who wants to go first?
I can go first.
Okay, Amy, I will, you should have sharing power, so you can go ahead.
Now I'll go second.
Amy,
Yeah.
you want Ted?
Oh, I'm sorry. So Sarah, you wanted to go first?
No. Amy can go first. I'll just go.
Okay. Okay, great. Okay, so why don't you go ahead, Amy?
Okay, can everyone see the screen?
Yep.
So I did the drop NA function, and essentially this function has two different arguments. The first one is the data set, And then the second one is ... which is columns that you want to inspect for missing values. This function really works best within a tidy workflow because you want to pull from a specific column. So what I did is I kind of looked at just the first little rows of the data, and then I went through and I dropped rows based off of the column of sex. So here you can see that there is a total of 12, and then when you dropped the values for sex, there's 7. So there was 7. So then the other ones were missing. And then I also went through and did it for not specifying for anything. And when you do that, it essentially just drops anything that has an NA in it. And then I also went through and plotted it to show how it could be used for plots. So without using the function, when you're doing it for different species and the sex, you can see here that the NA values are kind of included in here. But then if you were to go through and add the drop NA function within your little workflow, they're no longer included. So it just makes the data cleaner. And then I thought that this was helpful, but it's mostly helpful, I think, when you want to just remove data from like a certain column.
Great. So Amy, one question. So can you drop multiple columns that have NAs? Or
Yeah,
drop
yeah, you can. That is what I did right here.
Mm-hmm.
I just left out putting a specific column in, so then it got rid of all of them that have the NAs in it.
Yeah, great. So the one thing I would add is if, like, for example, if you wanted to drop both NAs from columns like sex and species, for example, you could say drop NA sex, comma, species.
Okay.
So, but great. Any questions for Amy? Sorry, I have to rearrange my chat window because everything got all pear-shaped. Any questions? Okay. So drop NA is a very useful function. So there is the equivalent, which is it's called tidyr complete, and that will only return what are called complete cases. So that's so it will drop any row that has a value that is NA. So you do have to be careful about that. And we don't really have time to talk about like how you deal with missing values. That's a whole other conversation. There are lots of different approaches, and I've had this discussion with kind of a lot of other data scientists as to like, understanding what their workflow is. But there's a few approaches. I don't really like a lot of the theory. There's like a lot of terminology that I don't think makes sense, but I don't want to get into that. So Sarah, would you like, thank you so much, Amy. So Sarah, would you like to go next?
Can you guys see my screen?
Yep.
Okay. So I did the breaks pretty function. I chose this one because it's a little more challenging and relevant to the work that I do. The breaks pretty function lives in the scales package. So you have to remember to install that package and then bring it in through the library. The breaks pretty function is used to find the best fit breaks or intervals in a variable within a data set. So what I did is created a list, well, somebody else did, I found this online, that just included 2 dates between 2 months. And it's intuitive, you put in the argument of how many intervals you want in the break. And the breaks pretty should choose the best grouping of that interval. And so if you put in 2 within this kind of generic list, it'll create, as you can see, 2 breaks, but without any additional data because there's no granular data in this data set. You can also make it a little larger of a break number right here. And you can see the 4 breaks, 1, 2, 3, 4. As your data set becomes more complicated or your number of breaks become larger, breaks pretty, because it's so intuitive, might be smaller or greater or fewer breaks depending on how logical it is in your data set. So in this case, with this small list that I created of just these 2 months, I asked for 12 breaks, and the output for this visualization is up to 15, or this one's actually 18 breaks, even though I didn't ask for 18. So like I said, Breaks Pretty is found in the scales package and takes advantage of an existing R package called Pretty. So if you investigate the Pretty package, those are the same arguments that you can use. In practice, Breaks Pretty is most commonly used to designate the ticks or intervals of dates, times, and continuous variables in visualizations. So the best use for Breaks Pretty is to identify the intervals you want in your ticks in whatever visualizations you're using. So I decided I wanted to create a ggplot where my ticks were dependent on, the bill length in millimeters. And I added it to the scales continuous portions of the plot because I wanted to designate different intervals. And another thing I wanted to highlight in this example is that the default argument, if you put it in a number, is n. So you can define your break by n equals a number or just the number that you'd like. And when I put that output, you can see at the bottom that it created 6 along the x-axis, but only 7 along the y-axis, because that was the most logical fit, closest to the number I wanted. Is it helpful? I actually think it's really helpful. If you guys remember how we were doing breaks in our prior class, we were hard coding them, where Breaks Pretty allows you to simply put in a single line of code, and also makes it as intuitive and nicely packaged as possible. And that's all I have. Do you have any questions?
Great. Thank you, Sarah. Any questions for Sarah? So this is a really helpful, for finding kind of intelligent defaults. And oftentimes, you don't want to have to fuss over the numbers. You just want it to look reasonably good. So Breaks Pretty is very helpful for that. So thank you so much, Sarah. Okay, well, actually, why don't we do our last 2 presentations, if that's okay? So it's Lindsay and Lisa. Would you like to go now, or would you like to go later?
You can go, Ted.
Okay, why don't you go ahead, Lindsay?
Okay. Let's see here. All right, can everybody see that?
Yep.
Okay, perfect. So I chose to do geom tile, which is part of the ggplot package. So I, once again, load your library ggplot, and then I use tidyverse also. The data I chose to use was the food consumption and CO2 emissions from the Tidy Tuesday website. It's a pretty large data set, so Ted helped me kind of break it down into a more manageable amount, because as you can see, there are a lot of countries listed. So we subset it to just a few countries for the plot. So what is geom-tile4? It is once again part of the ggplot package, and it's a way of looking at 3-dimensional data in 2 dimensions. You can have an x-axis, y-axis, and then the fill or our z-axis. So I did country, food category, and our z-axis was consumption. You can also choose to put a legend on this plot if you want to. You don't have to, but it does kind of default to have a legend. But you can set that to false or true depending on what you want to do. So this is just kind of our starting heat map here. And once again, color, you can change the color. So the blue is just the generic color that Geom Tile does. But in my next code, I added the scale fill gradient and just put some color codes in there. And then you can see that it changes the color. Since everybody kind of likes their own color scheme or what they prefer to look at visually. So is it helpful? I think it's helpful, especially for specific types of data or if you have the right type of data to do this with. For example, we can see patterns in the data. In this one, we can see that the milk and cheese food category is a higher consumed category in almost all of the countries. So I think it's helpful.
Yep.
Anybody have any questions?
Cool. I wonder why Sweden eats so much dairy compared to everyone else. Any questions for Lindsay? So heat maps are really useful, as Lindsay has said, and oftentimes when you're comparing across a lot of different conditions and you've got kind of two sets of covariates you want to compare. So it's very cool. If we have time, I will talk about I will talk more about kind of how like clustering heat maps. We haven't had time to really kind of go over it, but if there is time, I'll talk about by clustering and heat maps. So thank you so much, Lindsay. Lisa, would you like to go next?
Yep, let's do it.
Okay.
Is that working?
Yeah.
Okay, so I chose factor relevel, and it sounds kind of silly, but I wanted to learn more about levels after what happened with my final last semester. For those of you I had for 511, Ted wanted me to share my cautionary tale. Case was 0 and control was 1, and I wanted them to say, I just wanted them to read as case and control just for graphing. And when I set the levels, I did control case, which was the opposite of what order they were in, and it flipped all my variables. Thankfully, I noticed it before I turned it in, but I had still done a lot of my final by the time I realized that. So factor relevel allows you to move any numbers of levels to any location, and I used the built-in data set diamonds because it had an ordered factor set. They can be ordered or unordered. Like unordered ones would be like gender and race. So in diamonds, cut is ordered from fair to ideal. So I just made a graph. Like we use the levels for visualization a lot. Like I don't know anything about diamonds, but just looking at this, I can see as cut improves depth, looks like it the range decreases, right? Just from looking at that. So if you mess up your factor levels, you kind of mess up, the patterns you would see in your data. So I included a bonus function here, factor shuffle, which just messes up your factor levels. And I don't know what other use it would have other than to demonstrate factor levels. So I included that there. And so if you do that, at first glance, this doesn't look too bad. But then, if you showed that, again, for those of you I have for the biostats classes, we showed that to Thwan, I'm pretty sure she'd be pretty mad at you. It's like, definitely cannot detect a pattern there. So for the rest of this, we're going to use factor relevel to fix this. So compared to the last couple presentations, it's actually pretty simple. So if you want to move one of your values to the beginning, you just have the name of the vector and the level you want to move. So let's see. So we know that fair is supposed to be first. So that's all we need, just cut and fair. So we have that part. And if you want to move it to a specific place, you use after argument. And so just, the number you want to move it after. So we want good to be second. So 2 is after 1. So after 1. And if you have a really long vector, or if you have a really long vector of levels and you don't know what the last value is, you can just use int. and it'll place whatever at the end. And then I just made a note, don't forget to capitalize your I and use M for it's going to give you an error. And you can also use it to move multiple values by just making a vector of the values. And hopefully it's pretty obvious what the vectors need to be in the order you want them to appear in. So we want these to move into the middle. So that did that. And another really useful thing it does is you can add functions. So if you use sort there, it'll place it in alphabetical or numerical order. So just, you know, it won't set it back to the default. It'll just, in this case, it did alphabetical. If you do sample, it kind of does what factor shuffle did. I think it randomizes them. And reverse, well, rev, it just takes the order and does them backwards. These are the only functions it gave in the examples I was looking at. So it might be able to use more functions. I don't know. And just the last key point is that you can't use it to create a new level. If you try, it'll just give you a warning and ignore you. And it's helpful if you have a lot of factors and just need to switch a few things around. For this example, you know, probably would have been easier just to reset them at the beginning. But an example that popped into my head is if you were using race and you're fine with alphabetical order, but you have not reported, and not reported would probably go best at the end. So it would just be easy to throw that there at the end. And that's all I got.
Great. Any questions for Lisa? Yeah, so factor relevel, it does a very specific thing, but it's very useful. So we will be talking about ordering by a numeric variable in a second when we go more into factors, but this is a very helpful function to have in your pocket. So thank you very much, Lisa.
Thank you.
So let's take a 5-minute break. So it's 3:57. So come back at 4:02. And if you have any questions, just please let me know in chat. I'm just going to leave for a second, but I'll be back. So let's see, I need to pause recording. Already talked about the midterm. And again, don't forget to fill out the survey by the end. I am behind on checking attendance, but I will update that by the end of this week. Okay. So now I'm going into part 5. And so we'll get started. Come on, you can do it, RStudio Cloud. Okay, the first thing I just want a quick show of hands. So so RStudio Cloud just added what's called visual mode. So if you look in on the top right of our Markdown window and see where this A is right here, if you click it, it's kind of nice because this is what it's called. They just added this mode to RStudio, I think 1.4, but it's visual mode. And so you can see the regular text is formatted differently than the code blocks. Would you rather me use this or not? And just let me know in the participants tab. So I have 1 vote. I have 1 not vote. So, okay, so if you're more used to seeing it without this view, I won't use it. So I just wanted to offer that option. Okay, so I'm going to turn it off. Had this been available at the beginning of class, I would have used it from the beginning, but I understand now why, like, you know, you're so used to seeing this right now, why you wouldn't want to do it. Okay, so this week we are going to be learning how to do things with multiple tables. So we are going to learn and apply this function called bind rows. So you can combine rows from 2 or more data sets. Um, yes, so our studio doesn't need to emulate Jupyter. Haha. So we'll learn about the different kinds of joins and how they will merge data. So we're going to apply inner join specifically and left join to join tables on columns. And this will all be more clear as we kind of go on. There's more diagrams. We're going to standardize variable names. Oh, we actually already did this. Oh well. We'll do it again. We'll standardize variable names using clean names. So we're going to be talking about the difference between wide format data and long format data and how to use this function called pivot longer to make a wide data set long. So this is a lot of data is kind of in a matrix format. And the one issue with that with something like geom_tile is that it actually needs to be what's called a long format. And we'll talk about that in a second. We're going to learn a little more about factors, and then finally we'll wrap up with learning about functions and how to write them. And we may go over this again. So next time we'll be covering probably functions, lists, and if there's interest, I'll cover dates. If not, we'll cover the first part of per. Okay, so let's get set up. Okay, so let's talk about bind rows. So my previous student, Aaron Coiner, wrote this. So I liked how he set up a whole situation about this. So imagine your lab is part of a large consortium studying the effects of smoking. As a lead data scientist, you've helped oversee the collection and documentation of several observations for many variables of interest. So these are measurements that are recorded by multiple labs. So many labs within the consortium have accumulated data, and not all were following the guidelines you set for the tables. So he's just going to show you the first few rows of the tables, and he's just going to show you those so it's easier to see what's going on. So if we look in the data folder, you'll see that we've got these 3 different data sets. So smoke_1, smoke_2, smoke_3. So here he's just showing you the first. He's just going to show you for smoke 1, he's just showing you the first 5 rows of smoke 1. So you can see it's got 5 columns. So primary diagnosis, tumor stage, agent diagnosis, vital status, morphology. So here's the data set for smoke 2. So they were playing nice. So you can see that they have the same column names. They have the same in general. So when that's the case, but site 3, they were rebels, I guess. So they decided to put vital status in a different location. They used agent diagnosis with spaces. So these are all examples that Aaron himself has encountered in working with consortia. So these are real world examples, even if this isn't real data. So let's talk about the first 2 data sets. So these were the people who were playing within the rules and painted within or colored within the lines. So there is a function called bind_rows that basically lets you glue one data set to the bottom of another data set. And so you can see how we do this. We use smoke 1, and we're going to pipe it into bind rows. And bind rows has the argument of smoke 2. So that means we are going to bind the rows of smoke 1 to smoke 2. So let's take a look at that. So our original data sets had 5 rows. You can see we now have 10 rows, and it appears that it has combined everything correctly. So it's a really useful function, and oftentimes, when I'm getting data, I do a lot of work with data that comes out of instruments, and for example, like the microscope might generate one file for one sample or something like that. and it's in a standardized format, but I want all of the data together. So I can use something like bind rows to like basically get all of the data kind of into a single table. So like we talked about, you know, these two labs, and they were playing great. Lab 3 is basically a rogue lab. They just want to make things difficult for you as an analyst. So rather than putting columns in the standard order specified, they switched them around. They changed the names of the columns. And so how are we going to deal with this? How are we going to merge like lab 3's table into our other lab with our other labs? So Aaron pointed out that we do have the option of clean names. So we're going to clean that data set up. So smoke 3 clean is going to go through clean names, and let's take a look at the take a look at the column names. Hey, like I said, clean names is a pretty intelligent function. So it converted everything to what we call snake case. Again, snake cases, there's no capitalization, and its spaces are represented by an underscore. So these names seem to actually be consistent now with the new data set, but the columns are in the wrong order. Uh-oh, so what happens if we actually we try to bind smoke 1 to smoke 3 clean? Is it just going to try to map, is it going to map the right columns together? So if you see, like we've got, so smoke 1, that's the first 5 rows, and then smoke 3 is the second 3. And you can see it was smart enough to map the columns by name because they matched. So this is a very handy function, and it does a lot of kind of nice things to do for you. Any questions about bind rows? Okay. So this might be, if people are having kind of trouble with kind of formatting their parentheses and their brackets, I'm just going to show you something that's built into RStudio that might help you. And if it's just under, I believe it's under code. Where is it? And if you select rainbow parentheses, all of the parentheses and brackets at each level is going to be a different color. So this might be helpful to you if you're having kind of issues. Like for example, if I added something like in here, like C, you can see that the parentheses, these matching parentheses are a different color than these. So this might be kind of a visual kind of aid to help you in coding. So again, that's under code. And if you just want, you would just want to select rainbow parentheses. Okay, so Sarah's asking a question. So can we create a column with the name of the file it came from? So yes, we can. So I can show you, I'll show you how to do that in a mutate statement, but it will take a little more programming knowledge to do that. Like if you had a file full of folders and a folder full of files, and you wanted to do that. So if I just wanted to say that, let's go back up to smoke 1. So what I can do here is I can add smoke 1. So if I say mutate, then file equals smoke 1. So what this is going to do is it's going to create a column called file, and all of the values in that column is going to be named smoke 1. So that would be kind of how you would do it, the tidyverse way. But like I said, you're going to need a little more information to do this, to do this like in a programmatic fashion. So yeah, and this is going to be like when we go over once we go over lists and functions, we'll be talking about per, and this is going to be the number one example we're going to be doing, is like basically getting a list of files and then loading those files up as separate data frames and then gluing them together in a way that you can kind of, you can tell where the files came from. So good question. Any other questions about bind rows or anything? Okay, so now I am on around line 108, and it says renaming columns using select. So I just want to show you two ways that you can use, you can rename columns on the fly. So you can rename columns when you're in a select statement. So if you wanted vital status to become vital stat, when you select it, you can just say, you can just add this equals. So the normal select statement would be like vital status, comma, primary diagnosis. But if you wanted to change that to vital stat, you would just put the name at the beginning and then put an equal sign. So some people don't really like this. So I'm going to show you the other way to rename columns as well. So you can see now that we've selected the vital status in primary diagnosis columns, and we renamed the vital status columns vital stat. So if we just wanted to rename the vital status column, and I think this is a little cleaner, I don't kind of like renaming and selecting at the same time. I think it's a little, sometimes it can be make the code a little hard to read. So what I might do is I might rename it first and then I might select it. So you can use the rename function, and it's a function that's by itself. It's not like mutate or anything. It's just its own kind of tidyverse function. And you can see that I've just said rename vital stat is equal to vital status. If I wanted to call primary diagnosis PD, so I could say PDs. So you can see primary diagnosis got renamed to PD, and then vital status got renamed to vital stat. Any questions about rename or select? Okay. So let's go on to joining tables. And sorry, this was displaying. I need to fix this. So I just want to show the actual image. And for some reason it wasn't just, it was displaying fine before, but I'm just going to add it. So before we can even get into joining multiple tables, we need to talk about the naming conventions. So this is a nice diagram, and it's from Garrick Adenbui. He's now working at RStudio, but he had these great examples and these kinds of moving GIFs of tables. So when you are joining tables, you are going to join them on, so let's just talk about the terminology. So when you join tables, there is going to be what's called the left table, and that here is labeled X, and there's going to be a right table, and that's labeled Y. And this is important because it's talking about the left table and the right table is important because there are specific joins that favor the left side or the right, or the left table or the right table. So that's basically that's what the terminology. The other terminology I want you to note is that each table has what's called a key, and this is like some sort of unique identifier. And in the case of when you are merging tables, like the keys are going to have to be, they have to kind of represent the same concept. So what does that mean? We'll go over in that in a second. So like in order to join our two tables, we somehow have to map the rows of our left table X to the rows of the right table Y. And so we do this by joining together rows that have the same kind of key value. So we'll go over this in a second, but like, so for example, if we wanted to join these two tables, we see that we have that table X has a key of 1 and Y has a key of 1. So we know to merge those two rows together. So the end would be like 1, X1, Y1. So if this is too abstract, we're going to have a more concrete example in a second. So by matching rows with identical keys, we can put together tables that incorporate information from both tables. So I'm teaching databases in the other course, but I tried to really pare this down as much as possible so that it really kind of focuses on the kinds of tasks that you will probably do in your stats work. So again, I have to, sorry, I have to add this code block. Okay, so let's talk about what's called an inner join. And you'll see the reason why I need to have this illustration up and running. So let's start at the beginning. So we have our two tables, our X and Y table. So we're going to do what's called an inner join. So we're going to, the way you specify that in dplyr is inner underscore join. And then you've got your X table and your Y table. So what does it return? So we notice that both the X table and the Y table have keys of 1 and 2. And those are the only ones that it has in common. So table 3 has a key of 3, and X also has a key, a row with key is equal to 3, and Y has a key with row is equal to 4. So because those aren't in common with each other, we're not going to merge that information into our new table. We only want the rows that have keys in common. And I probably didn't explain that very well. So are there any questions right now? And if this seems a little abstract, again, we're going to have a more concrete example in a second. Okay. So let's talk about the joining syntax. So this is, if you are just doing this with two tables and you're not doing this in a tidy workflow, this is what it's going to look like. Sorry, I'm going to highlight this. So, well, that's not even, let me change the, well, so it's inner join. So the function again is called inner join. So your left table is going to be on the left. And then your right table is going to be the second argument. So yeah, sorry, your left table is going to be the first argument. Your right table is going to be the second argument. And there is this argument called by. And by is your map that tells you which columns go together. So in this case, we have a column called key column X in table X. And then we have a column in Y called key column Y. So this is telling inner join which columns to match on in each table. So this is the way if you just need to join two tables and you don't need it in a tidy workflow. But the tidy workflow way to do this is that you are going to take the left table. You start with the left table, so that's table X. You pipe it into inner join, and you provide the argument Y. So unfortunately, I don't know why. They should have just called it left and right, but this is in inner join and all of the join syntax, the right table is called Y. So you can say table, so your right table is table Y. And then you're going to point out the key column in each of the tables.
And Ted, you have a question about
Yeah.
if they have the same? Yeah.
So what if the column header is the same? So that actually simplifies the syntax. You can if the column is just the same, you can do this. So like say they were both called key column, or you can do this. Because the name is the same, you only have to put in one side here. So, and again, that's why it's so important to talk about the ordering of the tables, because the map is always, so the key column for X, and this is for your left table, is always going to be first. And the column for your right table, key column Y, is always going to be on the right. Did that answer your question, Sarah? Okay, so I need to. So let's talk about left joins. And this is why I really like Garrick's illustrations, because they are it's very clear about what's going on. So the left join is going to have everything that the inner join has. So it has these two rows that have matches. So key matches 1 and 2. But it's also going to retain any other rows in the left table. And you can see here, because there's no match on the right side, there's actually missing information here. And so the key and the thing to think about the difference between inner joins and left joins is that they answer different kinds of questions. So if you had like a list of people in your left table, and you said, I want all of the people who made orders, then you would do an inner join. But if you wanted a list of people on whether they of all of the people on the left side, whether they had made orders or not. So what I'm calling orders is I'm calling the right table here. So you would still get information about that, about the person in the left table, even if they didn't make an order. And this is kind of a subtle point, but it's just something to kind of think about when you are merging tables, because sometimes you want to retain all of the rows of one of the tables. And this is, I don't have time to think about this, to really talk about this, but this is an issue in bioinformatics that we deal with all of the time is, we want to have a table that's kind of comprehensive and merges as much information as we can, but we don't want to throw out information if it doesn't have a match in another table. So how are people feeling about this? Is this clear as mud? Yeah. And that's why I think these GIFs are so great, because they really if you try to illustrate this without these GIFs, it's really hard to explain them. Okay, so let's actually work through an example. Like we talked about the left table, right table. We talked about keys, and we talked about two kinds of joins. So I'm going to load in these two tables. So as a motivating example, so say we are a hospital and we have all of this patient information, but we want to merge in information. So the patients have had some sort of lab, like a white blood cell count. And we want to merge that information into our patient table. So we have a row for each time a patient got a white blood cell count. So, and this is kind of a real world example because, you know, data comes from multiple places. So in this case, it would be coming from a lab system, which is not integrated into our electronic health record. So we're going to have to actually make a join on the patient table. So let's load this data up. So this is both in this patient example folder. So the patient table is sheet 1, and then the white blood cell table or white blood cell count table is in sheet 2. So let's take a look at patient table. So we're going to use again, in the parlance, we're going to use patient table as our left table. So you can see it has, it's a pretty small data set, but it's really to kind of just show you and take you through it. So we've got a column called patient ID. And so this is just kind of a numerical identifier that the hospital uses to kind of identify their patients. We have their first name and last name information, age, and date of birth. So this is a really kind of contrived example. In a real world situation, a lot of this might be depending on who was kind of accessing the data, a lot of this information might be de-identified. So let's take a look at the white blood cell table. Yeah, so, okay, Byron, like we're going through the example, so hopefully this will help. Okay, so let's look at the white blood cell count table. So you can see that it has two columns. So it has patient ID, and so that corresponds to this patient ID column here. And we have the value we want to merge in. So it's called WBC underscore value. So let's actually do an inner join. So remember, in our parlance, our left table is patient table. Now we're going to do an inner join, and we need to specify our right table with the Y argument, WC table, BC table. And then we need to tell inner join which columns to match on. So in our case, remember the left side corresponds to the name of the column in the left in our left table, which is our patient table. But it has the same name as in the one in the white WBC table. So its patient ID is equal to patient ID. So this is the left table, and this is the right table. So now you can see that it only returned 3 rows. So we've got our patient ID, we've got all of the information that was in the patient table, but we've also added this column called WBC value. So why did it only return three rows? So let's look at the actual patient IDs. So does 2, 3, so this is the patient table. I want you to compare it to the WBC table. So does patient ID 2333 exist in the WBC table? And you can use yes or no. Yeah. So you can see it exists here. So likewise, patient ID 7359 exists in this data set. Patient ID 1414 also exists in this data set, but here we've got a mismatch. So patient 8424 does not exist in WBC table, and 4409 doesn't exist in the patient table. So that's why we only return 3 rows. So what I want you to do is I just want you to modify this code to do a left join on patient table and WBC table and tell me how many rows it returns. Paste your code into chat and tell me how many rows it returns.
Sorry, what was the question? Was it the number of rows that it ends up with?
Yeah, number of rows. Okay, so Brady, yeah, so she got 4 rows. Okay, it looks like everyone got the code right, 4 rows. Okay, is there anything that you notice about the 4th row? So I'm just going to change this into left join here. Yep, looks like everyone got it. Yeah, so there is no WBC value here. So that is the thing about left joins is, you know, it retains all of the information in the left table, but there's no match for it in the right table. So that stuff is missing. So are there any questions about inner joins or left joins right now? So these are kind of the main ones that you're going to be using. Right joins are very similar to left joins, except they retain all of the values in the right table. So I'm going to show you what that looks like. So if I change this to right join, so you can see that we had that patient 4409 and they had that white blood cell count of 4,000. So it retains that information, but we have no information for date of birth, age, last name, and first name. So depending on how you set this up, left joins, it might be interesting to do a left join or right join. I usually tend to put the table that I want to put priority on the left, and then I just always do a left join. But some people do like the option to do a right join. So again, this hopefully, you know, you're not going to have to do this too often in your career, but like this is something that you might encounter. And so I just want to give you the machinery to be able to kind of deal with it. So yes, so the question, so you can do what's called an outer join if you want to retain all of the rows of both tables. I don't really use outer joins, but you can, oh, okay, so it doesn't exist. Let me see. Oh, in dplyr it's called a full join. So if we do full join here, you can see now we have 5 rows in total. So this is a row that was missing the white blood cell count value, and this is a row that was missing a patient value. Did that answer your question? So I just want, again, this is probably, this might be new to you, and we do have you do one of the exercises just so you can kind of try it out and so you can kind of understand what's going on. But I will say that, you know, hopefully the data has been kind of merged for you. But if someone gives you the data straight from a database from different tables, you now have the ability to at least aggregate the data. So you have two tables and you can basically merge them together.
Ted, what does do you know what this function does if you have multiple columns with the same name, like when you're trying to join them together?
Yes. So number one, like data frames can't have the same name. There is a way to merge on multiple columns, but the way you would do it, I believe, is something like this. So if I had an age column, you could do something like that. I'm not sure if this is answering your question.
I was like kind of referring to say like if there were multiple blood tests done and more than one data set you're trying to join together says WC value, but they're actually from different tests. I just wondering how it handles that.
Yeah, so this has to do with kind of order of operations, and this is kind of a subtle point. So if I had multiple blood cell tables and I wanted to merge them into a patient table, what I might do first is I might merge the white blood cell tables together with something like bind rows. So I would have a single white blood cell table, and then I would do the join to the patient table. Does that make sense?
Yeah, I think so. So would you like would you have to change the name of like one of the columns so it's like white blood cell 2 or something like that? So like if it's for the same ID, is that kind of just like what you have to do?
So this is actually a good point. So if there are multiple values, and say this patient had multiple white blood cell tests, that is actually a really good point that this doesn't illustrate. So what is going to happen is that two rows, because there are two matches for patient ID on the right table, there's actually going to be two rows that are created in the new table. So you will have two rows that have patient ID 2333, and they're just going to differ in terms of the white blood cell count value. And this is just kind of
okay. That makes sense.
Yeah. So good question. I should incorporate that next time when I teach this next time. That's actually a really good point. So yeah, and a lot of times, you know, you will have duplicated data when you kind of do a join like this, and it's just kind of inevitable. But this is really why you need to understand kind of the structure of the tables when they're given to you. So like if rows are duplicated, why are they duplicated? What does that correspond to? Are they different measurements for that patient, or what does that correspond to? So yeah, so Sarah's question is about like for like a long to wide data set. So we're going to be talking about that in just a second. So good questions. Any other questions about joins? And like I said, there's a full course on this. This is like part and parcel of the databases course. So this is I'm just kind of giving you the basics that you need for merging in together. So question? Okay. And again, this is you have to deal with on a daily basis. I'm sure Eric has had to deal with basis. So I just want, it's about giving you the machinery to do this. Okay, this is the last of Garrick's GIFs, but this will be useful. Did I really not? Just a second. Oh. Let me see if I got up. Just a second. This one is actually really important. Okay, so this is the original verbs were called spread and gather, but very important. This is something like when you're using something like geom table, and you're given data that's in kind of a matrix format. So this is kind of the original format. Sorry, I wish there was a one that didn't move. You can see that we've got multiple. We have 2 IDs, and we have columns for each of them. Sometimes doesn't like things to be in that format. It likes it to be in what's called a wide format. And the difference is that, you know, these are kind of those, the columns are keys. And well, this seems a lot really abstract right now, but then your values that were originally in a matrix, they're now in a single column. All of these values here, these become here. So let's actually look at an example. So again, this is the previous verb spread or gather, and but we're called pivot longer. So let's do a concrete example here. So this might not feel as relevant to everyone because this is an example, but I just wanted that sometimes you get data in kind of a matrix format, and this is one way to kind of visualize and deal with it. This is the data. We often get data at the bioinformatics side that we have to kind of deal with, where the columns correspond to different patients. So these are identifiers for different patients here. And these are measurements. And these are measurements of protein levels, particular protein. So this patient had a measurement of P10 for 4.1. And this patient had a P10 measurement of 5.6. So what was TCGA10's KC and J9 measurement? So TCGA 110 and KCGA9. Yeah, 2.3 exactly. So this is often how data kind of comes to us, but it's not super useful for a lot of data manipulations. So if you really think about this, all of these measurements are kind of like, if I wanted to look at so the issue is really that the columns correspond to samples, and this prevents us from plotting things like P10 expression across the samples. So if I tried to do a ggplot here, I couldn't really show you, like, I couldn't compare the values in this row to each other because we're kind of restricted to our columns, because remember, columns correspond to variables. So we might be able to do gene symbol, X is equal to gene symbol, and then Y is equal to TCGA 110. But that would only give us the set of measurements for one patient. So, but if we wanted to plot what this P10 expression is across all of the samples, we can't do that. So this kind of matrix format, you encounter it a lot, and it has a special name for it. It's called a wide format. So like I said, what we need to do is we need to collapse all of these numeric values into a single column. And then we have a column that is perhaps called patient here that corresponds to, and there would be patient TCGA 110, or P10 TCGA 110, P10 TCGA 332. So these would be kind of new rows in our long data set. So let's look at pivot longer, and please tell me, okay. This is exactly what this is doing. So this is the wide format here. And now we are changing it so that we have all of the values into a single column. So that one, I have to say, when I first encountered it, it was really kind of a foreign concept to me. But let's talk about pivot longer, and hopefully this will make it more clear. So pivot longer takes calls, three arguments, calls. So these are the columns that you want to collapse together. And then you want, there's two arguments. So what do you want the column, the key column to be named? So that's names to. So we're going to take all of our column names. So in this case, let's come back. So all of our column names are X, Y, and Z, and we want them to be into our key column. And that's what this names to corresponds to. And then values to is where we want all of the values that are in the matrix itself to go to. So let's look at an example. Let's make expression example longer. So in this case, we are using, and this is part of that tidy select operation. So we can say calls. So you could put the individual patient column names in here, but we have the shortcut. We can use the starts underscore with function. And this is what's called a tidy select helper. And if you want to go through the learning tidy select tutorial, you'll learn more about these. So we want all of the columns that start with TCGA. We want our names to, our name column or our key column to be called sample. We could also make this patient if that's more clear. So let's call it patient. And then we're going to call our value column, we're going to call that expression. So let's take a look at what this does. So now you can see, much like, we basically took all of those column headers or those column names, and we moved them over into this patient column. And we moved the actual values in the matrix into this expression column. So this seems relatively useless when you first do it, but there's a lot of things that you can do with the data now. Are there any questions about pivot longer? Before we move on. And yeah, again, this was a bit mind-bending when I first encountered it. But so why don't we take a 6-minute break? Let's come back at 5 o'clock. And then I will go over how we're going to use this long data. And if you have any questions, just please let me know in chat. I will be gone for a second, but I will return. So just there was a couple of comments during the break. So Martin noted, it's wild to me how smart the pivot functions are. Every time I encounter them, I expect them to require way more inputs to make them work. Feels like the program almost intuits what I want. So there was actually a really, so Hadley Wickham's keynote from this year's RStudio Global was actually about this, because there was a previous, so like you can see here, the previous version of Pivot Longer was called, I think it was called, yeah, it was called Gather. And this was actually seemed to be very hard for people to use. And so they actually kind of changed they came up with Pivot Longer. And basically there was a lot of kind of, they had to kind of figure out a way that was a lot more understandable to people, because Gather was just very unintuitive. So it's an interesting talk. So it wasn't kind of magically that way. It was kind of the product of like seeing people make a lot of mistakes with the previous tidyverse verb. So there is a question about, so exporting data from REDCap. So that is the OHSU, I can't remember what it's like a survey system, particular for studies at OHSU. So if you've exported data from REDCap on a longitudinal study, is that considered a long data set? Yes, because each row is for a participant is a single data point. The other question was, is Pivot Longer analogous to transpose in Excel? So I said in response, I said yes, and then I was like, oh wait, that's completely wrong. So I'm going to show you, this is the equivalent of transpose. At least this works on matrices. So remember our matrix is called expression example. It's not quite a matrix, but it's enough that you will understand. So in our case, in the original example, so gene symbol, these were the columns. And transpose in our case made the columns rows and the rows columns. And because this isn't strictly matrix data, it doesn't quite look like the way you expect it to. If it was matrix data, I would have named, these would have been row names instead of their own column. I also pasted a link to the page, to Garrick's Tidy Explain page. So if you want to kind of look at that, there's lots of other nice explanations that he's kind of put up there. And I just really like, again, I really, oh, duh, he had the wide versus long. I should have used this one. But again, so yeah, I find his use of GIFs to be really helpful. Especially for understanding these things. So these are, a lot of these are called set theoretic concepts, and it's not always, I find these to be kind of the best way to kind of learn all of these. So there, for example, underneath all of these kinds of joins are different kinds of operations. So the idea of a union, or an intersection and things like that. But I don't really have time to go into that. But these are, if you ever take a database course and you need to understand what these concepts mean, this is a very useful page. So any other questions about making data long? Okay. So one of the things we wanted to do is we wanted to plot expression across a particular gene symbol. So what we can do is we can now create a box plot because our data is in that long format. Let's show it again. So again, we've got gene symbol as one column, patient as another column, and then our actual values as another column. So this is very much, this now lets us do lots of things. We can do lots of more kind of different ggplot things. So remember, we couldn't really plot across a particular gene symbol across all of the patients, but now we can do that. So we're going to map X to gene symbol, Y to expression, and then fill to gene symbol and make a box plot out of it. And so now you can see that the expression of some of these proteins is more variable than others. So like, for example, this RKIP it's very much the same across all patients. Whereas, you know, for mTOR, this seems to have the kind of widest spread across all of the patients. So, and this ties into geom tile again. So what we can do, so what we're going to do is we're going to take our long data set. We're going to make them into factors. And then I'll talk about this in a second. So this is another function built into forcats, which is a package that lets you manipulate factors, and it's called factor reverse. So what we are doing here is we're making gene symbol a factor, and we're setting the levels. So this is the order. And then what we're going to do is we are going to do a geom tile with that mutated data. And I'll get into okay. Let me take a look. Aesthetics must be. Oh, it's because I was being clever and I renamed my. So this should be patient if you renamed it patient. So now, just to kind of get to plot the data in matrix format, we did have to make the data long, but the plot makes the data wide again. But so why did I use this FCT reverse? So the default is ordering is to put the first one on the bottom, the second one on the second row. But we often read table or like any sort of tabular format from the top down. So that actually reverses the order that we gave it, so that it is in our expected visual order. So any questions about this? But again, like, you know, this is not something that you're going to encounter all the time, but there are going to be situations in which you need to make a wide data set long. And this is one way to do it. Another example, now that I think about it, might be survey data. So if you wanted to plot survey data in a heat map, so each column would correspond to a particular question. And so say you had like a table of questions and the answers were Likert scale, on the Likert scale. So ranging from 1 to 5 or 1 to 5, 1 to 3. I got in trouble with a survey person once when I suggested like one to like an even number of levels as opposed to an odd number of levels. They got really mad at, or no, an odd number of levels as opposed to an even number of levels. They got really mad at me because like the middle value doesn't, they thought that was kind of useless in general, and they wanted someone to have an opinion one way or the other. So yeah, so that was my story of run-in with survey people. So that's the story of Pivot Longer. You will probably think of other ways to use pivot longer. If you think about it, you find an example, please let me know. I'd love to add to this. This is relatively simple. So there is what is called the inverse function of pivot longer. There's also pivot wider. And part of your assignment for this week is going to figure out how to use it. So Martin is saying the whole no ambivalent value thing is one of my least favorite survey experiences. Sometimes you genuinely don't care about a thing one way or the other. This is very true. Sometimes you're just meh about something, and it's nice to have that option. Okay, so now we're going to kind of shift over into learning how to write functions. So again, this is in the service of like being able to start to learn how to automate things. So programmers have the saying, and it's called "don't repeat yourself," or dry. So their point is, if you're doing something once and you have to do it again, it's best to think about a way to generalize it and how to do it well. How to basically create a function rather than cutting and pasting that exact same code again. So this example, and this is what we're going to be talking about when we get into Per. So say you have multiple files that have the same format, and you have those file names, and you want to load them all into R, and then you want to glue them into a single data set. So part of doing this is that like you can think about ways to kind of write reusable bits of code that will work for not only like one data frame, but kind of on multiple data frames. So this is really good because the number one reason why you don't want to repeat yourself is if you made a mistake in that code, you only have to fix it in one place. If only like when you, like for example, like when I was doing this, I was producing these figures and I had to do the same figures for 3 different data sets. Instead of making the ggplot code for each of the single data set, I wrote a single function that would take each data set and produce the equivalent figure. So that it saves you a lot of pain and suffering. Like when you're first doing it, it doesn't seem that useful. But as you kind of start to have to do lots of things multiple times, it becomes really, really helpful. Okay, so let's learn about how we define functions. So we are going to take we're going to look at this code right here. And given what happened with for loops, I want to go over this slowly, and I want to make sure that everyone is understanding what's going on. Okay, so the first thing is we're assigning this into an object. And what are we assigning? So we have the sorry, I just realized how absurd this is going to sound. We have a function called function. And this is how you define a function. So the way to read this is that we're going to have a function called square number, and it has one argument, and that argument is equal to number. So like for example, if I had two arguments, like I said, number 2, I can just add another name here. So this defines kind of all of the inputs for our function here. So our inputs go in this go in the parentheses. So these are our arguments. And this is the code that we want to execute using the value of that argument. So we're going to do a calculation. So we are going to multiply our incoming number by itself. So number times number. and we're going to assign it into the value of output number. Finally, we want that just kind of, it just kind of will sit in the function, but we need to basically spit it out so we can actually get something useful out of the function. So for that reason, we use this return function, and this tells R, so return the value of output number. So let's run this. So I'm going to invoke it in a different way. So once you have defined that, you now have a function called square number, and you can call it like this is where the arguments come from. So you can say square number, and number is equal to 2, and you'll see now it returns 4. And if we do square number, number is equal to 4, it changes to 16. And like anything, we can take the output of this function and we can assign it into an object. So if I said square of 4, and I looked at, remember we looked at the values in the environment tab, so you can see square of 4 is 16. So that's the basic idea of a function. Are there any questions? I know this is really kind of confusing, but the thing to note is that the stuff in the curly brackets, this is code that uses this argument. Okay, so, well, let's try doing the exercise then. So what I want you to do is make a function called cube number that returns the cube of a number. And then I want you to test it out and make sure that it works. Yeah, okay, so the arguments, yeah. So the important thing to note is that you are the one who decides what the arguments are named. This doesn't come, these aren't predefined. So if I called this argument num here, then I would have to change this code to be num times num. Does that make more sense? So why don't you try doing the exercise and paste the, yeah. Okay, looks good, Jessica. Looks good, Stephanie. Looks good, Casey. Looks good, Bradley. Well, yeah, so that's one way to do it, Bradley. So you can use a previous function. So that's good. Let's see, where Casey, let me take a look at your code. Actually, that should work, Casey. I think that should be right.
Sorry, I think, yeah, the first time I wrote it in when I did like the actual function, I did square underscore number. So it,
oh,
yeah, so I decided to change it to cube to actually do what I just made.
Yeah. So Colin is, of course, Colin is being very terse. So this is probably the more Pythonic way to do it, I would guess. So you can do it the way Colin is saying, although I think you're missing a parentheses there, Colin. Okay, so looks like everyone got it. So if I named my argument num, what would I put on line 384? Yeah, so, and this is one case where everything has to be next to each other, I think. So let's try cube number 4. And you can see the cube of 4 is 64. So with just this amount of knowledge about functions, you can do a lot of useful things now. So if I could put a ggplot in here. So let's kind of make one. Oh, I think I have that in. Oh, that's below. We'll get into that in a second. Okay, so this is where we get a little more complex. And if you've taken a programming course, you've been wondering why I haven't gotten into if statements yet. And it's mostly because I feel like you shouldn't really show if statements until you can really show what they're for. So oftentimes, as a programmer, people will try to use your software in ways that you didn't expect them to. So sometimes you have to anticipate this. So maybe there's someone who tried to run square number and they put in the word 2. So if they run it, so this is, you can see that this is like a very kind of obtuse kind of error, non-numeric argument to binary operator. So what it's really saying is that you put a character in here and we didn't expect that. But you can actually use, you can actually check for this and you can return an error that makes more sense. So let's go through this. So this is, we're going to make a new function called square number improved. And we're going to start out with this if statement. So what goes in our if statement is a condition. So this, unfortunately, this is how a lot of these things are written. So remember so we're going to check for whether number is numeric, but we want to know what the negation of that is. So that's what this this exclamation point is. And that is a shorthand saying if number is not numeric, then we do something. So much like the functions, we have the curly brackets, and then we're going to execute code that happens if that condition is met. And in this case, our function, we're going to make our function, it's going to just stop executing. And it's going to, the stop function actually returns an error. It says your input was not a number. So if our number is numeric, then it's going to go through this. It's going to go through this check, and it's going to be fine. So this is a very common error pattern in programming, and this is called I can't remember what it's called. It's called the critical path, or it doesn't matter. But anyways, you're checking for errors in the input first, and if there's no errors, then you execute the function. Are there any questions about this so far? So I'm going to run this code. So we're going to try square number improved, and we're going to give it the word 2, and we'll see what happens. So you can see now that it told us, it gave us, how we called the function, and it returned our error message. So your input was not a number. That's a little more friendly than non-numeric argument to binary operator. But if we type in square number improved with the number 2, you'll see that it returns our expected value. That was probably a lot of programming and a little bit of time. So are there any questions, or please let me know if there's anything that you found confusing. Okay. So I will say that this gives you enough so that you're about functions that you'll know enough when we get into per that you'll be able to write your own functions to do something. And I'm going to go over a more concrete example in a second, but I just want to talk about error checking for a second. So one question I always get is, do you need to check for all errors? So for example, if someone put a square number improved, and then it was like, I put in a Boolean value, do I need to check for that distinctly? So this is kind of the art of understanding your users and kind of how they use your software. You don't need to anticipate all of these errors. You just need to anticipate the ones that you think people are going to commonly make. So if you were just giving someone, okay, so here's my R script, it has a function and you can use it. You know, you're probably not going to do as much error checking as if you released it as a package and like a lot more people were using it. Because, you know, if you give it your function to your friend, you can really explain to them exactly how it's meant to be used. A lot of the times you can't make that expectation with, like, you know, when you are distributing it out into the real world. So that's why you do want to think about doing some error checking. Okay, how are people feeling? Are they? Do you want me to go over this again, or do you want me to move on? Okay, I'm getting good to move on. Okay, great. So let's show a practical example of a function. That's the thing I always find like annoying when people show you how to program functions, is they give you really stupid examples and they don't give you something that's really that useful. Okay, so we're going to now make this function called count categories. And it's going to take an argument called df. Df is going to be our data frame. And what we're going to do is we're going to pipe df into count, and it's going to count our disease column, and it's going to return the number of counts. So this is something that you might do quite often. So say you had a bunch of the tables and a bunch of these data frames, and you wanted to, they all had a disease column, and you wanted to basically produce tables of counts for all of them. So I'm going to run count categories on my smoke complete data frame. And you can see now it aggregated by disease, and it gives us the number of counts. So this is, and again, like, you know, your arguments could be anything and your code could be anything in here. You could take df and you could put it into a ggplot statement if there was some sort of plot that you did very often. But one thing to note is that, note that disease here, this is hard coded. we can't change this on the fly. So that somewhat limits the usefulness of these kinds of functions, but they're still very useful. But there is, and if we have time, kind of at the end, we will talk about what's called tidyr, which will let us pass in column names. So for example, if I wanted to have a column to count argument, and that might be disease, or it would be set like disease. So we can actually make this we can make this function very flexible. And I'm not going to go into this too deeply, but I just want to show you that it's possible. So what this does is it takes this column name here and it puts it into the column to count argument. And so this lets me specify the column that I want to count. So here so we can do smoke complete. Just a second, let me get a column name. Where is smoke complete? Oh, I don't think I loaded it in yet, did I? Of course I didn't. Let's just run this on smoke 1. And let's do vital status. Okay. Oh. So now you can see that we selected vital status as our column. So I would say this is a very advanced topic. So if you don't understand it, please don't worry about it too much. But I will be happy to kind of go over this later because this makes your tidyverse functions to be even more. Okay, see you later, Eric. Yeah, I'll paste that code into chat just a second. Oops, that wasn't helpful. So this also kind of says something. So this is when you can see that I specified the value of an argument here. And this is how you specify default values. So if the default value of column to count here is disease. So if I just run count category smoke 1. Oh, sorry, that's not a, let's call it tumor stage. And then I do count categories. So the default value of column to count is tumor stage here. So Sarah, that's a really good question. So she's asking how does it know DF is a data frame? So that's a really good question. And the answer is that you write the code as if DF is a data frame. So like your expectation is that DF is going to be a data frame. Like I could actually test here. There is a function called is data frame DF, and I could put a testing statement here. So if it isn't a data frame, then we want it to stop. No data frame. But that is the thing. The arguments don't really define what the data are unless you check for them, if that makes sense. You could probably put something else in here and R would try to execute it. It would probably return an error. And that's part of why it's very important to name your arguments something that people can understand. So DF is often like, what we use for convention as a data frame. So this is the way kind of base R does it. There are ways to make it much more rigorous. And bioconductor does this, but I don't really have time to get into these kinds of object systems. But there is this very rigorous checking. So say data frame had to have a column with a certain name and the values had to be logical. For example, there is that ability to check that, but that's not built into regular R functions. Okay. So does everyone feel okay about functions right now? There's going to be an exercise. There's going to be an exercise in the assignment. So if it's confusing, please reach out on Discord. It is one thing that it does take some time to kind of really understand. And as you kind of keep on programming functions, it will become much easier for you. Yeah, Bradley. So yeah, these are all things that they are in the documentation, but it's not obvious. So that is kind of the nice thing, is that you can specify default arguments. Okay, so the last thing we're going to do is we're going to be talking more about factors. Unless there's any other questions about functions. And I'm not going to make you write functions by hand. The main thing is to, at this point, is to know how to read them. And know that we can basically use them. And what we will get to when we get to per is that we can basically, like, so if I had a vector of row names, I can apply the same function to that, or a vector of file names, sorry. I could apply that same function to that vector of file names and have it output something for each of those file names. So it could load the data in, it might clean the data, for example, and then return that. It would return the cleaned data frame. Okay, so we're going to talk more about factors. Now I'm on line 400, around line 465. So just kind of the last time I gave this, this was kind of a quick tutorial I made up on the fly about more about factors, so you can kind of understand what's going on. Okay, so we're going to load in our old friend Smoke Complete again, and we are going to make, we're going to use our mutate statement to make our disease variable into a factor variable. And it's called disease factor. And we're going to add a fourth value to these levels. And if you've spent any time with this data set, you know that there are not 4 different categorical values, but that will become useful to us in a second. So if we look at Smoke Complete, can see now that we have this disease factor, which is the same as disease, but it's a factor variable. So what I'm going to do is I'm going to compare to the same ggplot, the box plots. So I'm going to use disease, which is originally in character format, and I'm going to compare it to disease factor, which is now in our factor format. So this is we're just going to make a box plot, and it's going to be disease versus cigarettes per day. And as expected, the ordering is alphabetical. And remember, disease is a character column. So let's compare it to using disease factor. So that's the factor version of disease. And again, so you can see that our expected order was LOSC, CESC, BLCA, and BRCA. So you can see LOSC, CESC, and then BLCA. Well, what happened to BRCA, you might ask? Well, since it didn't actually exist in our data set, it is a permissible value, but it doesn't exist in our data set. Okay, so this is just kind of talking about, so another good reason to use factors is that you can specify what the permissible values are in your levels argument. So here we've got a character vector, and it's got LUSC, BRCA, BLCA, and CESC. But we only want to make these two our permissible values. So if we cast our character vector as a factor, and we only provide these two levels, this is what happens to our factor vector. So you can see it emits the fourth place, which is BLCA, and it emits the seventh and eighth place here. So this is especially helpful, you know, when you're trying to kind of consolidate, things, and there is actually a set of values that is not important to you. So you can basically make them kind of not exist. Because, you know, say that you're really only interested in this contrast between lung cancer and breast cancer, for example. Okay, so let's look at this factor REV. So what I'm going to do is, and this is much like when we were talking about relevel. So when showed relevel with the rev function. This is built into what's called the forcats package. And so what I'm going to do is define a third data set called smoke complete 3. And I'm going to take the disease factor variable, and it had a very specific ordering. And we're going to make it into yet another variable that we're going to call disease underscore rev. So let's compare. So this first one is going to be our box plot with disease factor. The second one is going to be our box plot with disease rev. So if I run this code, and so you can see that we plotted our disease on our y-axis here. So let's look at, this is disease factor. So we actually wanted LUSC to be on top, but as I explained before, the default behavior when you're plotting categorical data is that the first value is at the bottom of the axis, and then so on. But by providing that rev, that FCT rev, we now have reversed the order of the factors so it displays right correctly. So this is one thing that is very handy. One use for forcats that's very handy that you will often need to do. So this is another function that is extremely helpful. I would say that this is probably the most helpful function of all of them, and it's called FCT reorder. So what it allows you to do is it allows you to order the levels of a factor by another numeric variable. So what we're going to say is, I want you to sort the levels of the factor by cigarettes per day. And let's see what that does to our box plot. So you can see now that it's ordered by, they're ordered by kind of relative values here. So you can see it's by cigarettes per day. So it's, I think by default, it orders it by median. But oftentimes you will want to have kind of a sorted box plot or sorted bar plot like this. And this is how you do it. So this is, I would say, other than the kind of setting the permissible values, this is the other really useful way of using factors. So I just want to, are there any questions about this? I'm feeling that everyone is feeling kind of tired right now. So we just have a little bit more, and we can basically adjourn for the day. I'll stick around if anyone has a data set and they want to ask me about it, but we just have a little bit further to go. Okay, so there is a function called FCT collapse. So this lets you basically take a factor variable and collapse categories. So I'm only really interested in lung cancer here. So I want it to retain the lung cancer ones, but you can put define an other category, and then you can say that these are the values in the factor that you want to be called other. And so you can see now we have 3 categories, because remember we had defined the BRCA as a level. But you can see that basically we collapsed the BLCA and CESC categories with this FCT collapse function. So that's the last bit of everything today. So just want to mention a couple of other forcats functions. We've already seen a couple other ones. FCT recode. So this lets you recode values manually. FCT other. So that's kind of a specialized version of FCT collapse. It allows you to define what categories are in the other category. So that's all I have for factors. Do people want me to go through case 1, or are people just tired?
What function is that?
I'm just going to do a quick review of case 1. Yeah.
I'll stay for that if.
So I guess what I'll say is, if you're tired and you want to take off, you can take off. But if you want to learn more about case 1, we'll do that. So have a good night, everyone, and I will. Yeah. So okay, so I am going to go over into this. So I'm going to go back into the project folder, and I wrote this little thing called more case 1. So this is just, I was just kind of trying to provide more examples. And again, I'm sorry that we didn't provide kind of the is.na example. I tried to give you enough clues that you were able to do that, but just want to kind of go over this again. So this is just in your part 5 folder. It's just called more case 1. So just want to provide another example of making a continuous variable categorical. So we're going to take the bill measurements, bill length, millimeter, and we're going to make them short, medium, and long. And the point is, we want to be exhaustive in how we code it. So we want to cover all of the numeric range of everything. So here we're using a mutate statement. We're using bill class, and we're making a new variable called bill class. And we're using our case 1 statement. And again, like I tend to write the case 1 statements so that each case is on its own line. And the first part, everything to the left of the tilde is a condition. So when bill length is less than 39, we're going to call those short-billed penguins. And when bill length is greater than or equal to 39 and less than 48, we'll call those the medium-billed penguins. and bill length greater than or equal to 48, we'll call those the long penguins. So let's take a look. So if you look here, you'll notice that you know, there is a penguin that didn't have a bill length measurement, and so we don't call them anything. They're just NA in our data set. But you can see that, you know, this is less than 39, so they're considered a short-billed penguin, etc. So one thing I just want to show you is how to make sure that you're exhaustive in your recoding. So I'm just going to basically plot bill class on our x-axis, and I'll plot bill length on our y-axis, and I'm going to use this geom jitter argument. I think someone is going to present on this, but I'll just show it right now because it's just a nice way to visualize. And so you can see that there are no values for bill length that have gone into NA. So you can see that we cover all of the different values. And the geom jitter is just a way to kind of separate data that's very tightly clumped together. So it will separate it out on the y-axis. It doesn't really, the y-axis isn't really interpretable, but it's just so you can see all of the different values within a range. So that's one example. So here, this is just another example. I'm just trying to think of kind of things that you might do. So say we have, so both of our species and island variables are factors here. So if we want to, say we wanted to combine values from both of these, you can't mix factors. That's the one thing, is because they each have different permissible values, and if they don't match, then like R is going to say that makes no sense. So let's do a new case when. So we're going to say if the species is gen2, we're going to create a new variable called penguin type. So when the species is known as gen2, we want we want the label to be species, but we need to cast it as character because species is a factor. When species is Adelie, we want penguin type to be island. And again, because island is a character, we need to cast it as character here. And then everything else is going to be other. And so this is, so I think you have to go all the way down here, but you can see that, so Adelie, if this species is Adelie, then we want the penguin type to be the island name. Let's go down a little further. Right, there's a lot of Adelie penguins. So these are species equal to chinstrap. You can see they get coded as other. So let's look for some Gen2 penguins. So you can see species was Gen2. It got encoded as Gen2. So that's just a little bit extra about case when. If there's any other questions about it, like I'm happy to answer it. But
I'm just trying to understand like what the function is doing exactly. So does it, like, as it goes through each row, does it remove everything that I guess it qualifies for that row, and then like everything that's left is what it goes off of? Is that kind of what it's doing?
Yeah, that's a very good point to bring up. It processes this in order. So it looks for anything that fits this condition first, and it will cast it as species. Then it will look for everything that has species is this condition, species is equal to Adelie, and it will cast, basically return this value. And then everything else basically gets a value of other. Does that make sense? Yeah, so it's always in order. So that's one thing to keep in mind.
Yeah, that makes sense. I was just curious about that because when I did the assignment, I noticed that you don't have to put the greater than or equal to thing. Yeah, so I was just kind of curious what it was doing.
Yeah. Yeah, so that's in general, if I have a bunch of conditions in order, I will usually put them in order just because it makes sense to me. But there are a lot of times this can get you in trouble. I saw a data set where they were saying like, so if species is in Gen 2, or I can't remember. So, and then they had another condition down here with the same thing. So it's going to execute this. It's not going to check. So, and because it has gone through all of these cases that are Gen 2 and Adderley, it's not going to execute this code. So that's one thing to keep in mind. Usually when you do this, you want to have your categories to be mutually exclusive. So that's one thing to keep in mind. So don't try to kind of repeat things.
Okay, that makes sense.
Yep. Any other questions? So if people have data they want me to look at, I'm happy to do it now. And if not, you're free to go and have a good night.
So I think I know what my project, or what I would like my project to be.
Okay.
I found the Moore's Law database,
Mm-hmm.
and my partner does semiconductor research, so I thought this would be cool. So I guess the question is just like what companies where met the projection and who didn't.
So yeah, that could potentially be really good. So if you can send me like what the data set looks like, I just want to make sure that I mean, it sounds like a good research question, and I'm pretty sure you could answer that. But I just want to make sure. I just want to look at the format of the data just to make sure.
Sure. Do you just want the GitHub page, or do you want the CSVs?
You can send me the GitHub page.
Okay. Can I just patch it into chat real
Yeah.
fast? Cool. Boop.
Okay, let me take a look at it. Okay, Jessica, we'll talk right after Colin.
Ooh, your GitHub is dark.
Yeah, I have dark mode on mine. So are you looking at which data set are you going to look at? GPU, CPU?
Yeah, I thought that this would be an opportunity to merge these things, but I guess all the column names match.
Yeah, so the one thing is I'm pretty sure that these processor names are going to be different because these are different computing units. So I'm not sure you can merge it. You might be, yeah. But yeah, so I would just pick one of these tables.
Okay.
And so, yeah, you can ask the question designer, transistor count. And then you would just have to plot Moore's law on the axes. So you need to learn how to plot a function.
Yeah.
So that would be the only thing that you would need to do that. So I'm fine with that. The other thing would be like, I would like you to kind of drill into a couple of the designers. And if there's any like particular, like looking at, do they have date? No. Oh yeah, they have date of introduction.
Yeah.
So it might be interesting to plot like date of introduction versus transistor count or something like that within like a designer.
Okay. Yeah, that makes sense.
Okay, sounds good.
Cool.
Okay, Jessica, you want to show yours? Oh, I have to stop sharing my screen. Just a sec.
Yeah, I can put the GitHub page into the chat. And then, so I was looking at